Hello everyone, my name is Jayant Singh. I welcome you all in the presentation on convolution of discrete time signal. So let's begin with the presentation. What is convolution in discrete time signal? It is a powerful tool which determines the system output based on knowledge of system's arbitrary inputs and impulse responses. Discrete time signal can be represented by a summation of scaled and shifted discrete time signal. Y of n is equal to summation from k equals to minus infinity to infinity of x of k into h of n minus k is the mathematical way to express the output of a linear time invariant system based on an arbitrary discrete time input signal and system's responses. Let's see graphical illustration of convolution properties. In figure 1, we are having single impulse input which yields the system's impulse response. Now in figure number 2, a scaled impulse input yields a scaled response due to the scaling property of the system linearity. In figure number 3, now we use time invariant property of the system to show that the delayed input results in output of the same shape, only delayed by the same amount as the input. In this figure, we have used the additivity portion of the linearity property of the system to complete the picture. As we know already, any discrete time signal is just a sum of scaled and shifted discrete time impulses. We can find out the output from knowing the input and the impulse response. Let's see graphical approach of convolution through time. In step number 1, we have reversed the impulse response h and begin its drivers at time t equals to 0. In step number 2, we continue the drivers. If you can see that at time t equal to 1, we are multiplying two elements of input signal by two elements of the impulse response. Similarly, we have done for n equal to 2 and n equal to 3. If we follow this step for one more time, that is for n equal to 4, then we produce the same output as we have seen in the previous example. What we have done in this demonstration is reversing the impulse response in time, and as we have clearly seen that this yield the same response, same result as scaling, shifting and summing impulse responses. Time reversing and sliding across is a common approach to present convolution, as it demonstrates how convolution built up an output through time. Let me further explain using tabular method for discrete time convolution. In this example, we have two discrete time signals x1n and x2n, where x1n having values 1, 2 and minus 1, where 2 is the value of signal when n equal to 0. And in case of x2n having values 2, 0, 1, where 1 is the value of signal when n equals to 0. Now we will find discrete time signal yn after performing convolution of two signals x1n and x2n. As you can see, I have written down the values of x1n horizontally and the values of x2n vertically. Now what we are going to do is we multiply 2 with all the values of xn. Okay, so 2 when multiplied with 1 we get 2, and 2 with multiply with 2 we get 4, and 2 with multiply with minus 2 will get minus 4. Similarly, we will do for 0. 0 will be multiplied with all the elements, all the values of x1n. We get 0 into 1 will be 0, 0 into 2 will be 0, 0 into minus 2 will also be 0. And similarly for 1, we get 1 into 1 will be 1, and 1 into 2 will be 2, and 1 into minus 2 will be minus 2. Now what we're gonna do is we can write y of n by performing addition diagonally. So in the first we have 2 is the single value in this diagonal, so we will simply write 2 here, and in the second we have 0 and 4, so we will sum it up. 0 plus 4 will get 4, so we have written 4 here. And similarly in this diagonal we have 3 values, so we will add all of them. We get 1 plus 0 plus 4 will be equal to 1 plus 0 plus minus 4 will be equal to minus 3, so I have written minus 3 here. And in this diagonal we have 2 and 0, so 2 plus 0 will result in 2, and similarly we have left with the minus 2 in the last, so we have simply written here minus 2. So this is the output signal that we have get. Now what we have to find here is the value of yn when n equals to 0. So as you can see that I have drawn a vertical line through 2 and a horizontal line passing through 1. So the intersection of these lines is 2. So after adding that value with 0, that is diagonally, we get 2 as value. So this 2 is the value of yn when n equals to 0. Thank you so much.